All right, so for this section 2.2, we're going to be talking about what's called the slope of a line. Last time I would give you an equation. Your job was to graph that equation by creating a table. Now we're going to be looking at what that line is telling us and what we call slope. And a slope is is the rate of change between 2 points on a line. So for instance, a good example of what we call rate of change would be the speed that you might be traveling a car, like 60 miles per hour. That is a rate of change. You are traveling 60 miles for every hour that you drive. That is a rate of change. Another type would be $6 per calculator. I'm making that up off the top of my head. That is a rate of change. For every calculator you get, that's $6. That is a rate of change. All right, and the way we do that with a graph is we look at what's called the change in y versus the change in x. Another way we say it is the rise of a run. So if I have a y-axis, here's my x-axis, and I have some random line like this, I'm going to look at two things. I'm going to look at these 2 points, and I want to see what we call from here to here. Let's just kind of draw a little line. This distance from here to here would be my change in y. And then from here to here would be my change in x. All right, it's my rise and overrun. Now here's the thing about rises and run. My rise can either be up or down, and my run can be left or right. So rise can be either up or down. Okay, and this could be either left or right. All right, so for instance, if I gave you a number such as 3/4, and this represented my slope, it changed 3 and it in my y, and it changed 4 in my x. Would you think I would be going up or down by this 3? Well, hopefully you thought positive. Since this is a positive 3, it means I would go up. And if that's what you said, you're correct. And if you saw this as a positive 4, and positive 4 means you go right, you'd also be correct. But what would happen if I gave you -2/5? Well, this negative is telling me to go down, while this is telling me to go right. All right, so just kind of keep that in mind. The sign of that number tells you whether you're going up, down, left, or right. And it's always rise over run, the change in y over the change of x. Now, from a mathematical standpoint, we have this equation. We have this, where m is equal to y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. This m represents slope, okay? And these are the ordered pair. All of this represents the, for lack of a better word, it's the parts of a pair. Oh, wow, this is really bad. Parts of a pair of an ordered pair. That's not a really good way of saying that, Mr. Lewis, but it's the best way I can think of it. Let me give you a better example. If I give you 2 sets of ordered pair, I have 0, 1, and I have 3 and 6. Each one of these represents something. So this one would be my x sub 1, y sub 1. And this would be my x sub 2, and this would be my y sub 2. This is my first order pair and their corresponding pieces. This is my second ordered pair and their corresponding pieces. So if I wanted to know the slope between these two lines, it's just a matter of plugging this information into my equation. And I'll show you some more of that in just a second, and it should clarify things out a little bit more. Now, we have 2 types of slopes, all right? Our first slope looks kind of like this. It's going to be a line that goes in this direction. And notice what direction it goes to. It goes into a upper right, or the arrow goes into what we call the first quadrant, all right? So it goes into the first quadrant. If you ever see a line going in this direction, into the first quadrant, this is what we call a positive slope. Okay? The next one might look something like this. Notice how this one is going down into the fourth quadrant. Well, if you ever see it go into the fourth quadrant like this, you have what's called a negative slope. Okay? And so we have different types. Like for instance, I can draw a line that looks like this. Well, it's also a positive line because it's going into the first quadrant. And I could draw a line that looks like this. Oops, that was not a good line. That was more vertical. I can draw a line that looks like this, and notice how it's going into the fourth quadrant, so it's a negative slope. So if the line goes into the first, it's positive. If it goes into the fourth, it's negative. All right, so just a couple of things to talk about. So let's hit some major issues. It tells me to find the slope of a line, and in this part, we're really lucky. It actually gives me the 2 points. So recall a while ago, I told you that the equation for slope of a line is this. M is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now, this equation right here needs to be your best friend. You need to say it at night when you go to sleep. I don't care how you do it. You've got to memorize this equation. There is no way around it. You've got to know it. It's got to be your best friend because you have to know it for your slope. Now that we know what this equation is, all we got to do is plug in things. So I'm going to say that this one is going to be my first set. So this will be x sub 1 and y sub 1. That's for my first ordered pair. And we're going to call this my second ordered pair. So we're going to label it as x sub 2 and y sub 2. And now that I've got these pairs labeled, it's just a matter of plugging things in. So m is equal to y sub 2. Well, that's 9 according to what I've labeled. Minus y sub 1, which is 3. So I'll put that there. All over x sub 2, which is 2. Minus a negative 1. So minus negative 1. Now it's just a matter of simplifying things. 9 minus 3 gives me 6. And 2 minus a negative 1 gives me 3. Well, what's 6 divided by 3? In this case, it's going to give me 2. So my slope for this guy is 2. All right? Now, I'm going to do number 4 with you because this one's going to be interesting, and then I will leave you 2 and 3 on your own. So I'm going to do the same thing, but this time notice that it didn't give me the number, so I have got to find it. So this particular point would be, looks like 1. Yep, this would be 1, negative 1, and 2. And this point would be negative 1 and 1, 2, 3, negative 3. So those are my ordered pairs. So let's label this as my x sub 1, y sub 1, x sub 2, y sub 2. And now we're going to use that same equation again. Slope is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Plug our numbers in. Y sub 2 happens to be a negative 3 minus y sub 1, which is 2. All right. Over x sub 2 is negative 1 minus x sub 1 is a negative 1. M is equal to, what's negative 3 minus 2 gives me a negative 5. All right. And then negative 1 minus a negative 1 gives me 0. And when you see this, your instinct might be to say negative 5 divided by 0 equals 0. And if you did that, it is absolutely, positively incorrect. Why? Well, let's see what happens. If I take my calculator and I go negative 5 divided by 0, I get divide by 0 error. In other words, I cannot do it. And we'll be using one of these calculators very soon. I'll clue it out of there. I will do negative 5 divided by 0. Look at what it says, error, divide by 0. So what does that mean? It means that the slope here is what we call undefined. So this particular problem does not have a slope. Well, what do you mean? Well, it's a vertical line here. You cannot find the slope of a vertical line. It's not going anywhere. It just goes up and down, whereas with this one, it's going both up and it's also and down, but it's also going left to right. This only goes up and down, but it doesn't go left to right. So this one would be undefined. All right. So what do you think this would be? And what do you think this would be? So why don't you give it a try right now and find your slopes. What you should have got for number 2 was that your slope would be -2/3 or -2/3. Now it is possible, depending on how you did it, you may have gotten -2/3, or you may have gotten 2/-3, depending on how you set your problem up. And both of these are literally -2/3. -2 divided by 3 or 2 divided by -3, all are the same slope, okay? Just kind of keep that in mind, all right? The only this is one thing about negatives. When we're working with a negative fraction, that negative could go to the numerator or it could go to the denominator. And most of the time when we write it, we always write it outside of the fraction, but it's very useful to know, especially later on when we start to graphing using slope, that it can go to either your numerator or your denominator. It does make your life easier if you can remember that. All right, for number 3, notice that the slope was 0. This time, if you notice, you're not going up at all. You just are on a flat horizontal line. So there is no slope. It doesn't go up, it doesn't go down, so the slope is 0. All right, so your challenge problems, let's take a look at it and see if I want to give you a hint or not. 5, the back of the moving truck is 4 feet above ground. A ramp extending from the back of the truck meets the ground 10 feet from the truck. What is the slope of the ramps? I am going to help you just a little bit here. So let's pretend that I'm going to do a little bit of a graph here. And your truck, I'm going to draw a little truck here. You got a truck bed. Meep, meep. All right, so we got the back end of a truck. Let's go ahead and draw the whole thing out. Why not? And give it a windshield. Yep. All right, so the back of the truck, which is 4 feet off the ground, it's 4 feet. And you have a ramp that's going down to the ground, and that's going to land about 10 feet away from the trunk. All right, so you know that this is 4 foot above and this is 10 feet away. Now I'm going to help you with the picture, but I'm not going to help you with anything else. Your job is to figure out the slope of this thing. So kind of picture this on a Cartesian plane and what these actual ordered pairs might be. So you know that from here to here is 4, you know from here to here is 10. So what's the slope, okay? And there is another easier way of doing it, but I'm going to let you figure that out. All right, then 6. Which set of stairs is more difficult to walk up? Explain why. Well, I'll give you a little hint. Do you want your slope to be steep or a slope to be shallow if you're going up the stairs? Especially like you're going up hiking, if your slope is too steep, you can't hike. It's hard to go up the side of the mountain or wherever you're at. So just keep that in mind for number 6. And that's all I want to do in this video. So we're just doing some very basic, oh, wait a minute. You know what? I told you a story. I lied. I forgot. I got something to show you. One more thing. So 5 and 6, I want you to do on your own as your challenge problems, but there is one last thing I want to show that was not in the notes. So I'm putting this in here. It was not in your original notes, so I redid it. Is finding a slope from the table. So take a moment, pause the video if you need to put these numbers in your table, and then we're going to find the slope. So there's a couple of ways that we can do this. One, we could take this and rewrite it as an ordered pair. So like this one right here, we could say -2 and -5. And then we could plot this on a graph, and then we can do just like we did a while ago. We can do our subtractions and find our slope. But there is an easier way of doing this. The first thing I would suggest is you need to remember what slope is. It's a change in y over a change in x. It's your rise over your run. So let's just look at what's happening here. So let's look at the changing in x first. What did I do to go from -2 to 0? Well, I added 2. What did I do from 0 to 2? I added 2. And then I added another 2. Then I added another 2. Then from 6 to 8, I added another. And then another. All right? So what did I do from y? From -5 to -10, I subtracted 5. Then I subtracted 5. Then I subtracted 5 again. Then I subtracted 5 again. Then again and again. All right? So what's happening? I have a change in x of +2. I have a change of y that's constant of -5. So what's my slope? Remember, it's a change in y over a change in x. Or I like to say rise over run. You're going to hear me say this a whole lot more than this, rise over run. So what was my rise? Well, my rise every time was -5. What was my run? What was my x? It was a +2 every time. So my slope is equal to -5/2. I'm done. So I'm going to leave this one to you. I'm not even going to give you the answer in this video. So your job for just to do some challenge problems, 5 and 6, and then this little grid right here, table, I want you to find the slope. And I will see you in the next video. Bye-bye.